Hello. Right, sorry about that. Two different laptops wouldn't work, so we're now running off a USB key. So you're in the REST API discussion. I'm not going to spend a lot of time. We didn't see our video of me at the AWS Summit. I work at Huddle. I cycle to work and do 10,000k a year just commuting to work. And I saw a really cool bike stand in Portugal when I last gave this talk about 2 months ago. So, who knows what REST really means? It's a big question. It's like Agile. Everyone thinks they're doing it, but they're not. So what you really have to go back to is Roy Fielding had an original proposal from 2000. They originally called it HATEOAS. So has anyone heard of HATEOAS? Yeah, they don't like it because it's got the word hate in. So they're trying to rename it to Hypermedia API because it stood for Hypermedia as the engine of application state, which must be one of the worst acronyms ever done. It also came with this Richardson maturity model to see how well you were doing, which is whether you were using HTTP verbs, whether you were using rel links. But the reality is, Roy Fielding is the guy who defined it because he created REST. He did a doctorate. He did a thesis on how to use HTTP kind of concepts and methods in order to have an API. Very often, especially if you've just been to Barbados, which I had been after I wrote this slide, when you have arguments about what REST is, you get to talk about restafarians. Yeah, but what you talk about is Roy and his original ideas, and there are quite a few websites where people discuss openly what constitutes REST, whether it really is REST, and are starting to do patterns, which is good. And Mark Amundsen is one of the guys. He's from the NordicAPIs.com website, and he said, one of the most important bit is when you first hit REST, you think it's CRUD operations on a database. A select is a get is like your select in SQL. The delete is like a delete. The put is like an update, and the post is like an insert. That is not what REST is. It is not a CRUD model via HTTP. And the really important bit is when you're designing this REST API, your data model doesn't necessarily, that's in the database, it's probably not the model you use inside your code for describing domain business objects. You'd hope it isn't one-to-one. And it certainly shouldn't be the way that your JSON looks on the web, on your API, the resources you provide. Because they're not the same thing. The way they're used is different. So the worst thing you can do is directly in JSON, map it directly to your database table. So every time I change my database table, I have broken everyone who consumes JSON. So you don't want to do that. And that's an important first thing. So for those who maybe haven't seen REST or it's been very light, we'll do the anatomy of a REST request. What is a REST request? Well, it's a HTTP operation. Although for pedants, it doesn't have to be HTTP and it could be any transport mechanism, but no one does that. Which may include a message. So basically, looks a bit like this. If you were in Fiddler or something, or a browser trying to analyze the traffic, you get a URI. In this case, it's kind of faking how we do things at Huddle, how we would get a recent item from a recent items list. You have headers that explain who I am. So we have a verb, get, we have a resource, which is the URI we're getting, and then we have headers. So who am I? When was the last time this got modified? And you may have data, and it may be JSON. It could even be XML. You might support XML for those people who still have MSDN CDs and install stuff and believe in SOAP. Or it could just be plain text, or it could be an image, it could be video, it could be anything, to be honest. Nothing says it has to be JSON, it's just the easiest thing to consume in JavaScript and a Node.js server. So it's the kind of thing you're going to plumb in. What comes back? So you get something like that, not the easiest thing to read, even in a cinema. You get a status, something like 200 OK, or maybe it's 304 not modified. If you're unlucky, it's 400s where you're unauthorized or forbidden. If it's 500, you've got server errors. But you hope it's a 200 that says, hey, it's all OK. You get things like content type, like application/JSON, telling you that what's coming below is going to be in JSON format. Last modified headers to allow caching. Oops. Then you have JSON XML, or I said plain text when I come back. And you might have these hypermedia API links. So this is what really makes it REST. The idea that we have a set of links that tell you what you can do to that resource. So in here, you can see we have a type of document, and the links on document are to delete that document from the list, the actual get that document from the list, and an alternative way of getting to the document, which is actually to go to the website and look at the document. So that's how you can go to our web client. So that's escaping the API and going directly to a browser. Now, when I talked about REST a couple of years ago, it wasn't GraphQL that everyone was talking about. It was gRPC, because Google had brought out this RPC language for communicating between processes. So it's a remote call system, always connected. So HTTP2, very fast, binary protocol, so none of that JSON stuff, and procedure-based rather than resource-based. And for those of you who are old enough, and I've got too many grey hairs, it's a bit like Java RMI or Corba, or if you really, anyone do DCOM in the Microsoft world? Right, if you were there, you wouldn't do it again, right? So I would not go down the RPC route. RPC is really great for internal systems which are tightly coupled, maybe, but even then you're relying on the idea that you're actually calling an object method that isn't on your machine, and it's maintaining the state and lying to you as if it is on your machine, and it all involves stubs and proxies, and it all becomes quite complicated. So I'd try and avoid that if I were you. GraphQL is a different matter. GraphQL, I think, has a really good position against REST, which I'll probably answer in a question, because someone's going to ask a question on standard IO or what slide IO of what about GraphQL. So where do you start if you're designing an API? Well, the thing you don't start with is coding. That's a really bad starting place to immediately code your API out. You need to consider who the API is for. Is it human users, or is it going to be automated users? Quite a lot of our APIs at Huddle are used by system accounts. So we have customers who want to trawl through the documents and tasks they have inside Huddle, and they will iterate through them, and they will change them and identify new things that have been updated, and they all do that as a system user. They don't do it as a real user. Of course, even when it's a system user, there is a user who programmed that system user to do this, and so you'd like it human readable. So it's nice if that's why you kind of go, SOAP and XML were a bit rubbish. So JSON's much easier to read. And as I said earlier, you might have a model on the server that doesn't fit all your clients, so you may be doing different APIs for different clients. And that's actually where GraphQL can come in, because it can hide your really complicated REST APIs and kind of summarize them into a digest almost for different clients. And that's where the two actually fit together quite well. So what are you saying? You're saying, am I designing for the server or for the client? Am I designing for the business? It's that typical architecture type discussion where we balance security, reliability, and speed, and don't give anyone a proper answer, right? Because there's always a trade-off, and you have to have one. If security is really important, you're going to go down on the speed level. So you're trying to work out who's going to use it, how are they going to use it, and how are we going to minimize the number of calls to our service and maximize how fast things load in the client. And that can be different from mobile users. If you are writing using an API on a mobile device, what you actually want is a few really big chunky calls, not loads of little small calls. On the web, you're probably after small calls, because you don't care if you have to keep scrolling down a page on an infinite scroll, because latency is not an issue. On the mobile, you really want to get as much stuff down in one go as you can. So it does make quite a difference. So what we do is we have a Slack channel for API design at Huddle. And everyone puts in a proposal. They say, here's how it could work. Here's the resources. Here's the verbs. And then we all argue about how it should be written. The worst thing is no one argues at all, because no one's read it. And then we have to poke people to read it. And then the discussion really gets going on what exact wording should be used, where the IDs are in the URI. And that's because what an API is, really, is a contract. You are saying, I'm publishing this way of talking to me, and as a consumer, you've got to use it in the way that I've told you to use it. So if I'm going to publish an API, I need to document it, and I need to document it well. How many people have used a library or a framework where the documentation is appalling, and you really struggle to get a handle on it, and you have a go at that person who made the library and say, how could they not have done the documentation? Then you write your own API and you're crap at writing the documentation, because that's the boring bit, you see. That's the bit that's really hard. And so you've got to actually be quite clear about what you expect can come in. REST doesn't really have a discovery mechanism in the fullest sense, so you can't guess what the schema is. You can't go, please tell me what it might be. So it's quite hard. So you've got to really document it. But you can use things like Swagger and things like that. There are tooling that allow you to make this easier for yourself. And for the person, if someone's going to write the documentation, please read it if you're consuming an API. If someone's actually bothered to write it and it's good, then you really have a duty to read it, because it'll save you loads of time of cocking things up, I tell you now. The other thing is, only use what you need. So one of the best tips I can say for REST is, just because they give you back all this data in a response, you don't need to serialize that into an object in your client. If you only need the document title and description and a created date, and you don't need to worry about authors or how many versions, don't store that in your object model. If they ever change the JSON API, the JSON that's in there, you won't care if it's one of the bits you don't use. So that's a really good thing, to not couple yourself tightly into the exact data that's coming back, especially if you're not ever updating it and you're more of a consumer. So as I said, documentation's the key. Swagger, API IO. The more you document it, the more people like QAs can test your API for you, and they can test it in tooling, and they can use Postman to do test queries. All sorts of nice things start to happen, which reduce the likelihood that your API is not going to work properly. Now, how do you version APIs? Because this is a gnarly thing in the REST world. Is basically, you just put v2 in the URI, and that's it. You've got a new version. It's not the way to do it. It's really, really not the way to do it. The important bit is what causes, or rather, how many versions exist. Well, you've got clients who expect this version. You've got a message format version that might vary. You've got an API on the server version. You've got a documentation version. The thing that you're not going to change in versions is the resource name. You should not be putting a v2 in the URI, because that's the thing you're really not changing. If that resource, the whole point of the internet was a URI is a pointer to an exact thing that shouldn't change. You should not get page not found. You shouldn't get Microsoft saying, we have moved this page, go to the new place. Because that's not what really should happen. You really are trying to say that's that, and this is the exact place it will be, and it will be there for all time. So that's the one bit that shouldn't have the version, is the resource, the concept of a document. But what it might have as a message and how it formats it could have versioning. So it's not adding just a version to the URI. So you're trying to use extension strategies, things like optional fields, optional data that you can handle. So you assume people might not send you everything back, and that's okay because that was the old client. And you might have to do new resource URIs if you eventually have to do something radically different, because you've restructured how your data is in the database and you really aren't going to get the same thing back. One of the other things you can do is, remember we had a content type. So you can have a requested content type, and you can actually request version 2 of this JSON. You can actually version it based on the content type if you wanted. So the URI stays the same, but you put a header in saying, I want the enhanced version of this. And back comes the enhanced version. And then you're allowing the client to make a call to you saying, I want this version, and you know it's going to come back correct. And then you don't have to do all the work with optional stuff that you would otherwise have to work on. So this is how you kind of extend. So you can't take anything away. You can't change how it processes. You can't say, oh, we're now going to be optional for this data, and it doesn't matter if, we're not always going to return it, or it doesn't matter. You've really got to really make sure that it works exactly as it used to. And one of the best things you can do is monitor who's using your API. So it's really vital that you do understand especially if you've got third-party customers, or even if it's just components in your own server. You might have components on this server and that server, all talking to your API. You want to know who's talking to it and when they've got updated so that they're using the new stuff, because that's the point at which you can turn off old versions. So we log every API call, and we log the client ID, which is like Android or iOS or a PC or the website, and we know who's using our system. More importantly, we know which external companies are using it. So now, if there's only one person using it remaining, we can talk to that customer and say, can you update it so it does this, this, and this? And if they do that, we can turn it off, and we can move them to a new version of the API. And that's why you've got to formalize how you communicate this. So we give people 6 to 9 months notice that we are going to take away an API to give them time to get their code in line so they can cope with the change. Because without that, we'll lose customers. They can't integrate with our system anymore. When it comes to renewal, and it's thousands of pounds, and we've pissed off their development team, we might lose the contract. And that's not our aim. Our aim is to keep them, make them sticky by making them integrate in our product and make it so Huddle's essential because it works really well with their existing systems. So how do you introduce ones? Well, as I said, anytime you create a new resource, so if you're going to change any of these, you're really changing it massively. And this is the summary I had. If an existing client does not produce the same results with the same resources, you've broken the API. And we've had that inside of Huddle, where teams have changed something, and then it broke the Android client, and they said the Android client's broken, isn't using it properly. But we didn't change it, but you did, because you missed out a header. You did things where, you have legitimately changed it and broken our software. So we want to have some patterns and strategies, because REST was all a bit, Wild West, and everyone did their own thing initially, and it was all getting exciting. So deprecation, how do you get rid? I've talked that we can tell people with 6-9 months to go that we're going to deprecate something, but how can you do it gently? Well, what you don't do is just put server 500s. Let's get rid of the idea that we just start throwing 500s at people immediately and we just switch it off one day. You can do elegant deprecation. So if anyone used capture in their own website, at a certain point, Google were going to stop supporting version 1. And what they did was, to our customers who were hitting our website, if they hit the capture, 1% of them in the last 3 months were shown this if if the customer hadn't upgraded. So instead of showing you a little HC letters all swirled around that you had to type, it told you to talk to your whoever software this is and get them to upgrade it. So that meant we got an early warning that actually we'd been a bit slack and hadn't upgraded the capture library, so we had to do some work. So it didn't just stop because they could press the refresh and then they got the normal letters, but it meant we had an inkling that something was coming. When Microsoft turned off Groove Music because they gave up on doing music, and they've given up on doing the mobile anyway, but it used to be able to detect a song, a bit like Shazam can just listen to any song and tell you. So instead of just giving a 500, when it detected a song now, it sends back that the song title, the album or the artist is song unrecognized, the album title is This Service is Retired, and the band's music continues. So they can put fake values into the return to tell users on both the phone and Windows 10, the desktop, that by the way, we can't do music recognition anymore because we've stopped doing music. Instead of just going error, which is what it would have done otherwise. And that gave them time to take it out of the product. And it eventually disappeared out of Windows 10 that you could do recognize a song with Cortana. So the other thing that you can do to handle this idea that we're moving the API on is something called a BFF, which is obviously stands for Best Friends Forever, if it's in a teenage girl's Snapchat chat. But otherwise, that's my girls, putting that all over the place. But in ThoughtWorks, call it back end for front end. And this is the kind of GraphQL type thing. In Huddle, we've got Python, little Python BFFs that sit in front of our new Tasks API and pretend to be the old tasks API. We've moved the whole of tasks out of one database into its own database. This is breaking a monolith into microservices. We created a brand new API. It has different semantics. It has different resources. There is no way it looks like the old one, but we've put a BFF in the way. And that means we actually can provide the old API to a handful of mobile clients. It's not the most performant way of providing that API, but it guarantees we don't break them. We've moved all our code on so that it uses new stuff, and as people upgrade all the platforms, we'll stop using the BFF, and eventually we'll discover the BFF isn't used by anyone, and we'll be able to turn it off. So that's a real result. The other way you use BFF is you can actually do things like aggregation of calls. So you might have a list of 20 recent items. The way it works at the moment, the mobile client goes out and says, what's my recent list? Here's the 20 items, and it says, I'll go and get the details of every document in 20 separate calls. We could put a BFF in the way that says, give me my recent list and all the document information in one call so I don't have to make 20 calls the moment I hit this recent list. And we'd do that in a BFF rather than trying to write a REST API on that basis, because that makes more sense. So, remember I mentioned earlier that we had a delete link and a self link and an alternate link. So, one of the things we can do as a pattern is using links to construct the user interface. So this has an advantage. Instead of something like the web client saying, hey, given this document, what permissions do I have? Or having some hooky permission set, we just don't give them the links. So we don't give you the delete link. And if you haven't got the delete link, you know you can't put a delete button on that page because you don't have the ability to do it. And that means you can build the user interface based on the links provided in the URI. That is the Hypermedia API. This is exactly how your web pages work. If you go to Google and you search something, it shows you a load of links. You didn't know what those links were going to be. It's the top 10 searches. There's a few AdWords over here that are special links. You click on them, you go to that website. You don't know where you're going to go from there because it gave you the links. And that's how you navigate to the next bit. You didn't need to know everything all the way. And that's exactly what you're doing when you say, hey, you've given this resource. Here's the way you delete. Here's the way you edit. Here's the way you do this. So this links can reflect the permission you might have in a document, and for us that generally means I can edit this document and do things like download it, or I'm only allowed to view it and I can't do things like download it. So that's how we use it to construct it. So we've got a nice secure system where we can have granular levels of access to documents. Now the problem we have is it should reflect permissions, but we decided to also make it reflect state. And that was a bit of a mistake. So we decided to put in a web API, a WebSockets API. So we got push mechanism. So when you're editing a document, you can see if it gets unlocked, and we can magically unlock it or add any comments and tell you that a new version's available. The only problem is when you went into that document and it's locked, we decided that means we don't give you an edit link because it's locked and you're not allowed to edit a locked document even unless it's you who's locked it. So along comes this WebSockets notification telling us it's unlocked, and we can't make the edit button appear because we never gave it the link, because we didn't just do permissions, we actually did the state of the document as well as permissions. So this is where you have to be careful about how you construct that set of links. Of course, you could say maybe we should have, set that so it worked differently. Maybe we could upgrade the API now and always give people an edit link, and then put in the client saying, hey, if it's locked, I can't edit. But you're now pushing a load of logic to the client you'd like to leave at the server. So what our plan is to probably put an extra link that says an edit button if it becomes unlocked. So we'll give an extra link to allow the edit button to be there, and they know you would be able to edit, except you just can't at the moment because it's locked. Because if we change how that edit link gets delivered, we've changed the API and we'll break stuff. Does that make sense? I know. Caching. So the other thing we do, I mentioned headers earlier, last modified and if modified since. You can use these to do caching. So when we get a piece of content from Huddle, quite a lot of the time, we give you a last modified header. If you send that back to us on our next request, if modified since, and we know nothing's happened in the meantime between that to that document, we just give you 304 and no content in the response, no body. So that means the client can say, hey, I thought I had the document 2 hours ago. Has anything changed? No. Well, that's okay. I can just use what I've got. And for mobile clients, that's really good because we've got everything stored in SQL-like databases locally, and we don't have to pull the data down if we don't need to, and we don't need to save it back to the database because we know what we've got is valid. So this is really cool. There's also something called Etags. So Etags is the other way of doing this, and this is based on a hash of the resource or a hash of the version number. There is an issue with if modified since and last modified is it's accurate per second. It is possible to have a race condition where you get a version of a document and in the same second someone updates it and you will not realize it's changed. If you've got a really busy server or really finicky QAs who push 10,000 requests a second into the system. So one or the other. So the Etags is the other way of handling it, which is kind of, you don't really want a strong Etag, almost in my head, because that's the hash on the whole resource, which means every time you need to say, if I got it now, what would the hash be? I have to get the data from the database, create the JSON, create the hash, then check whether it matches. That's a really long-winded process to do. So it's better to do it on the version and make sure that your versions are accurate in your system. So you say, hey, we're on version 7 of this document. If anything changes on it, we'll up the version number. And that's a much nicer way of doing it. And then you can avoid using things like SQL or Postgres or whatever backend DB you've got. And you can use something like Redis to do very quick cache busting. Yeah, so in the real world, I mentioned earlier that we broke the Android client because they decided not to have a last modified header. Actually, the iOS client it was. The iOS decided, well, if you're not going to say last modified to me, I'm going to request it every time. And every time I get that list of recents or list of tasks, I'm going to ram through every task as well because I know my list changed. Or I can't tell if my list changed, so I have to get all the data again. So we did have a chat with the team and said, no, that header is part of the contract. You weren't meant to change it, so we added the last modified header to the BFF, and it stopped the iOS app going into absolute overload onto our API, which is what was happening in the meantime and making us really busy. You could say we could modify the client app to do things properly and not use the BFF and actually handle the new situation. But how many of you develop mobile apps? Anyone? How long does it take for customers to update? 6 months? 9? Who knows? So you really can't push someone to update their mobile apps directly. So you cannot, even if you own the mobile app and you give it to your customers, you can't force them all to update really quickly. So it takes 6 months to flush, at least to flush a version of a mobile app out of the system. So again, we track who's using it, and we can actually email them to tell them they're on a really old version and can you get off this damn thing because we were about to stop it working. One of the other patterns you have, you may have called an API that gives you a 429. This is too many requests. So some of our customers are really chatty, and if they chat to us hard, they can prevent other users being able to use our system. They basically do a DDoS attack, a denial of service attack. So what we do is certain clients, we can say, hey, too many requests, come back in 30 seconds. And they back off. Even if they don't back off, we still really win because it's a really quick thing to give them this 429. It's not a long process that we're going to go through. And we don't have to go to the database. We're not consuming a load of resources on our web server. We'd still like them to back off properly, but even if they don't, we're okay. And it's much lighter load. So it's really good if you think you're going to have someone chatting to you too much to start implementing this and tell them right up front that you're going to do it and that they have to respect it. The other thing we have is there's a really good async pattern in REST. So one of the goals we had was every REST call should be under 200 milliseconds. So every API call, it's actually almost a test failure and prevents production release if it's over 200 milliseconds in time on a regular basis. But you know there's stuff that we're going to have that's much longer than 200 milliseconds. Something like, I'm uploading a video, can you make a preview of it? It's 2 GB video. That's not going to take 200 milliseconds to convert. Or equally, some of the searches we execute are going to be complicated and take a long time. They won't be fast either. So what you can do, you post to a progress endpoint and say, hey, here's my search query in the file system with this date range, these tags, these accounts. It's quite a complicated search. And it returns 202 accepted and then gives us a link that says, here's what you need to go to check if we've finished. And you keep polling that link. And you keep polling and polling and polling until that link eventually just says, hey, here's where you can go to get the result. It either redirects or it gives you a link saying it's finished. Here's the URI to get your search results from. And that's how we do quite a lot of our long-running operations. The interesting bit is a C# developer who was writing the normal API said, can I use async on my API so it returns control straight away and frees up my thread unless it goes wrong a bit later and then I return an error code? And you go, no, because that's not how async works, because you've handed back control to the browser and effectively given them a 200 as if it's worked. You can't suddenly go, can I have that 200 back and give you a 500 server error? So this is a much better pattern, in fact, because you can happily say, I've accepted your request, and then 1 second later, as you're polling it, it can tell you, by the way, there was an error. Here's what went wrong. Here's what you need to do to fix it. So it's possible to do an error on this pattern as well in a really nice managed process. Another thing we have, and it's one of the other things that people hate with REST is, at times when they first hit it, is I want to update just one property, just one, on a very complicated resource. So do I have to give you all the JSON and do a put, which calls it to update that resource and fill out all 30 fields, of which one of them has changed? Well, there are occasions, and in our case it was a status property, is that while we have say a task, and it's api.huddle.net/tasks 123 for task 123, and you would get the whole resource, we can do task/123/status. And that's a resource that's only the status property on a task. So the only thing it returns is whether it's read-only or it's completed or pending more likely. And that means you can also do a put to that status. So you now have a resource. By the way, you can do patches, but everyone who's actually written a patch call, was it pleasant? No. So no one understands them enough to debug them. You'll spend a lot of time explaining to people how they work. You are much better off doing this very simple put that just puts the status flag or read-only flag in this URI. You know how to put one bit of JSON. Yeah. And when you do that, the really neat trick is to return back a full version of the resource afterwards as well, with a header that says, hey, here's where this is really from. It's from tasks 123, and it's everything for the task. Because we had bits of the system where the web guys have to do a get to get the whole resource. They then change the status. They then do a put on the whole resource, and then they do a get to make sure they've got the right stuff. That's 3 HTTP operations. Instead, they're going to move to this mini put, where they just put the status and get back the new version of the object, and it's one HTTP call. Remember that if you're doing your API calls correctly, with cause, every API call is 2 calls to HTTP, one to get the cause header and an options, and the other to do the API call. So we go from 6 HTTP calls down to 2 if we go to a mini put. And that's quite an up in performance. But you only do it for things like, say, status, where you really wouldn't care if the rest of the resource has changed in the meantime. You've got to be a bit careful about what you choose to do with this, because you're effectively saying someone else could have edited another few bits, but it's okay to change just this one little bit independently, and it doesn't have an effect. So this is what we had with the updating a file request status. This is exactly what we had. So that's the 3 calls they had to do, and we're moving to this put with a status. So they're very happy. And it also indicates what the business process was. If you're auditing that API call, we can actually say someone changed the status. If we don't do that, what we get is someone changed the entire task. It may have been status, but we're not sure. So you have much more encapsulated what the person's trying to do and what the business objective of that call was. So it's a much better result all round. Over-consuming, I mentioned we shouldn't really consume everything. If you don't need it, why would you do it? We have a desktop app that just allows you to easily, when you download a document, it can open an editor and then monitors it on the file system and uploads new versions. It makes life a lot easier. It makes the workflow really simple. They decided, well, a QA was testing for invalid URIs put into the personal website of the user profile. They did that, checked that it didn't cause any bad side effects in the web application, and then the next day his Huddle desktop wouldn't work because he couldn't launch it because they loaded the whole of the user profile down at boot time, and they actually deserialized the personal website address into a hard-typed .NET type called system.uri, which can only accept valid websites, valid URIs. Caused an exception. They didn't bother handling any exceptions around that bit of code, so the application blew up and stopped working. So you could actually edit someone's user profile and stop them being able to use one part of our product. And the real annoying bit about this is nowhere in Huddle Desktop did they use personal website. Nowhere did it get surfaced. They didn't go to it. They didn't show it in a dialog. All they did was say, well, if I've got this JSON in the API, I'm going to make it an entire object model that matches exactly that JSON, just in case we need it in the future. So I'd well advise against doing that, because some companies will change APIs without telling you, and if you're not using that bit of data, it won't break you. Another one, Android decided that when you get back types of tasks, it would look for it being a task type, a case of task, a case of approval. We added file requests, and it blew up because it said, if I've got tasks and approvals, but I can't handle anything else, so I'm going to have an error every time that I get something I've never heard of. We add a new type of task, the Android application stops listing tasks at the point where the first task is not a type of task it knows how to deal with. The reality is you should be keeping things extensible. So what it should have done really is say, I can only show these tasks. If there's other tasks, I'm just not going to show them. And maybe tell the user, by the way, there were some tasks I couldn't show you. There's some type of stuff that is a mystery to me. So that's how people extend APIs. They may give you new types of items, and you would be wise to not try and handle them automatically because you're not quite sure what they are. Equally, anyone programming .NET and they use first or default type things in link? This is effectively what the Android guys did. They decided not to look for a link name and just took the first link. The link order changed in a BFF, and then their app stopped working. In REST, you look for the rel on a link to work out which link it is. You don't rely on it being the first one in the list. Please don't do that. So we had to change the BFF to redo it because we couldn't re-release Android to all thousands of users simultaneously, so we had to change the BFF to put the link in the right order. So, resources for you. I know it's been a bit of a rush, but this is a good one to get. All these slides, by the way, will go via my Twitter we'll have a mention where they are on GitHub, GitHub/WestleyL, and they'll also be uploaded by the committee or the organizers as well as part of the post-conference stuff. But the links are, you can actually download Roy Fielding's original This Is REST document, which is quite cool that you can still do that. Nordic APIs has a really good discussion of everything related to APIs. There's a Slack channel that just chats about things like this that you can enter and join. And there's also BizCoder has a really good patterns, and one of those is that mini put and the progress end pattern. So there's guys are attempting to create patterns so that just like we have singletons and things like that, we can discuss REST patterns and use them, and everyone understands what it means to have a mini put. So yes, and that's it. So you can find me at Westley L on Twitter. And you can ping me, DM me, or whatever if you need to get a link out of me. And normally someone pings me saying where are the slides, and then I upload them to GitHub and then put it on the Twitter so everyone finds out. And I very occasionally blog on my website, not as much as I should do. Thank you very much.